Okay, this is our second reduction formula video. This example says if in is equal to x to the power of n e to the minus x, evaluate I3. So first of all, we're going to use our integration by parts to get started. So typically what you do is you let your u be equal to a function such that du by dx is a simpler function. So if your u is equal to x to the power of n, du by dx would be n x to the power of n minus 1. Now this is a simpler function than this, as a power is reduced by 1. So it is simpler, might not look it, but it is a simpler function. And then your dv by dx is e to the minus x, which means v is minus e to the minus x. Your in then is equal to, this is your uv, so minus x to the n e to the minus x, and then minus of your integral of v du, but it's minus minus because the v is minus, so it's minus minus, so it becomes plus integral, and then it's going to be n x to the n minus 1 e to the minus x. Okay, so that's what we have got. I will just do one thing. I'll just change this a wee tiny bit. I will take the n outside the integral, so it's n upon the integral of x to the n minus 1 e to the minus x, and remember your dx, which I'd forgotten a second ago. So that's what we've got. Okay, now if you have a look at this, this is your formula. This is in. In is x to the power of n, integral of x to the power of n e to the minus x. So this bit, by definition then, is in minus 1. So what you've actually found is that your in is equal to minus x e to the minus x plus n times I to the n minus 1. And this is called your reduction formula, and it will only work for n greater or equal to 1, and that's because of this bit here. So n has to be greater than or equal to 1, because I0 would be the lowest you could go to. So we're going to use this reduction formula, and we have to find, it says for us to evaluate I3. So let's just work through I3 and how you would get I3. So I3 would be equal to, so just putting in 3 into the formula just above it there, would be minus x e to the minus x plus 3 times I2. Okay, so your I3 is built up with I2, so we'll have to look at I2 then. So I2 then would be equal to minus, oh, sorry, I've missed an n there somewhere. There should be an n here. There should be an n here, which means that should be an n, which means that should be a 3, apologies. So your I2 then is going to be equal to, putting that into the formula, is going to be minus x squared e to the minus x, and then plus 2i1. So your I2 is made up of your I1. Your I1 then would be equal to minus x e to the minus x plus 1i0. And I0, I would then work that out. I0 is, so using the original thing here, I0 would be the integral of x to the power 0 e to the minus x. So let's just put that in. That's x to the power 0 e to the minus x, which is the same as just anything to the power 0 is just 1. So it's e to the minus x integrated, which just works out as minus e to the x, and then plus your c. We'll worry about the c at the very end here. Right, what I'm going to do is build up backwards then. So I'm going to build back up to my I3. So I'm going to work out what my I1 is first of all. So my I1 then would be minus x e to the minus x plus my I0. And my I0 was minus of e to the minus x, and then plus my c. My I2 then is going to be minus x squared e to the minus x plus 2 lots of that, minus x e to the minus x minus e to the minus x, and then leave your c outside again. And your I3, I'm just about squeezed on there, I3 then would be equal to minus x squared e to the minus x plus 2 lots of minus e to the x. Oh, sorry, where do we get to there? My I3 then was minus, sorry, ignore that one altogether. We're looking at this line here. So my I3 is minus x cubed e to the minus x plus 3 lots of your I2. So let's just write that down. It's going to be, it was minus x squared e to the minus x, and then plus 2 lots of minus x e to the minus x minus e to the x and plus your c, and then we're just got to tidy that absolute mess up. So that's going to be minus x cubed e to the minus x plus, in fact it's going to be minus in this case, minus 3 x squared e to the minus x. And then you've got 3 times your 2 is 6, so minus 6x e to the minus x. 3 times your 2 times your minus 1 again is minus 6 and e to the x, and then plus your c. So let's have a wee look at this and see if this is correct. That looks good to me. And what you could do as well is you could, for this one to make it a wee bit prettier, is pull out minus e to the minus x, which would leave you x cubed plus 3x squared plus 6x plus 6, and then plus your c at the end. And here, notice what we did was we kept the constant at the end of each stage to avoid having to adjust it at each stage. Otherwise, it would have been very complicated. You would have 3 c's and 2 c's and so on. Would have got very complicated. But the c is just a constant, so it's something at the very end. Just leave it there, and that's you. Okay, quite a few more examples to do on these then. Next one, it says if the integral, if in is equal to the integral from 0 to pi over 2 of sine nx dx, show that the in is equal to n minus 1 over n upon in minus 2. And then hence find I5 and I6. Okay, right. First thing we want to do is we want to rewrite this thing as your in is equal to the integral from 0 to pi over 2 of sine n minus 1 of x times sine of x dx. So that means your u is sine n minus 1 of x. Your du by dx is brackets n minus 1 times sine to the power of n minus 2. And if you differentiate sine, you also get cos of x. And your dv by dx was just sine of x. And if you integrate that, you'll get minus cos of x. So your in then is uv. So it's going to be in a square bracket. So that's going to be minus cos x times sine to n minus 1 of x. And that's between pi over 2 and 0. If you would watch the first video, you'll remember I'm putting in the limits. It's going to save you a ton of time. And then it would have been minus for the next one, but your v is minus, so minus minus becomes positive. So save yourself a wee bit of time. We'll also pull out the n minus 1. Then that's integral from 0 to pi over 2. This is my uv, my v du. So that's going to be sine of n minus 2 of x times cos x. So that's cos squared of x. You can probably see where we're going with this. And then fire your limits in for the next bit. This will save you a ton of time. If you put pi over 2 in, cos of pi over 2 is 0. So that's going to get you 0 for this first bit. And then sine of 0 is just 0. So that's going to get you 0 for the second bit of that. So that whole first bracket just becomes 0. So brilliant, disappears. And then we have n minus 1 times the integral of 0, pi over 2. And then cos squared we know is the same as 1 minus sine squared. So that's 1 minus sine squared of x dx. So your in then works out to be n minus 1 times the integral from 0 to pi over 2. And that's going to be sine of n minus 2 of x minus sine of nx dx. And what you have, remember what your first thing was. In was the integral of sine to the power of nx, and that's what you've got here. So you've got in is equal to n minus 1 upon, I'll use a square bracket. This first one here is just in minus 2, and this one here is in. So that's a messy bracket there. So that is what you have got, almost like your reduction formula. Let's just multiply that out. You'll have in is equal to, that's going to be n minus 1, just leave it as a bracket, times n minus 2, in minus 2, and then minus n minus 1 times in. We want to make in the subject, so we've got that in, we'll bring the n minus 1 times in across. and then sort that out. That's just going to be, when you multiply it out, you're going to have in plus n times in minus an in. It just works out as n times in is equal to n minus 1 times in minus 2. And then your last line of working out here, you're going to have n minus 1 over n times in minus 2. And this is valid, again, for n is greater or equal to 2, because the lowest you can go is I0. And that's it. Okay, excellent. We've done our reduction formula. We now need to use this reduction formula. So we had to do two things. We defined in, and we're also going to write down what my original thing was here so we can see it. Originally, in was equal to 0 to pi over 2 of sine to the power of n of x dx. So we'll need to use this and this to do these questions here. So I'll leave those there so we can see them. Okay, first thing we want to do is find I5. So using the formula on the left-hand side, I5 is going to be equal to 4 over 5 times I3. So your I3 is going to be equal to, and it's going to be equal to 2 over 3 times I1. And I1 we can work out. So I1 using the formula on the left is going to be from 0 to pi over 2 times sine of x dx. And if you did that out, integrate sine, you remember you get minus cos, and that's between pi over 2 and 0. So that works out to be, that's going to be just minus cos of pi over 2 minus minus, which is going to be plus cos of 0. And if you did that out, you're just going to get 0 plus 1, so it's just 1. So then put that back in. That means your I5, therefore your I5, and you could build up to it as well, but I'm just going to jump in. My I5 was 4 over 5 times I3, and I3 was 2 over 3 times I1, which we now know is 1. And if you do that out, you'll get 8 over 15. Okay, I think the next one's actually a wee bit easier, the I6. So we'll use this reduction formula on the left again. I6 will be equal to 5 over 6 times I4. I4 is equal to 3 over 4 times I2. And I2 is, I2 is 1 over 2 times I0. And I0, put 0 into this formula on the right-hand side. Sine to the power of 0 is just 1, so it just becomes the integral between pi over 2 and 0 of 1 dx, which is just x between pi over 2 and 0, which is just pi over 2 minus 0, which is just pi over 2. Therefore, your I6, remember it was 5 over 6 times I4, which was 3 over 4 times I2, which is a half times I1, which is pi over 2. So your I6 is 5 pi over 32. Okay, two more examples to go, unfortunately, here on this video. Oh, no, it's one more example. It's a fairly long example. Okay, difficult one here. It says, using the identity sec squared of a is equal to 1 plus tan squared. To find a reduction formula for this thing, and then hence evaluate whatever we've got to evaluate. So first of all, rewrite this thing as I as the integral from 0 to pi over 4. So we're rewriting this thing here, and we're rewriting it as tan n minus 2 of x times tan squared of x dx. And also then we can substitute in tan squared is equal to sec squared x minus 1. We will get this thing. We'll get your in is equal to the integral from 0 to pi over 4 of, and it's going to be tan n minus 2 of x times sec squared of x minus 1 dx. And then if you do that out, you're going to get, that is the integral from 0 to pi over 4 of tan n minus 2 of x times sec squared of x minus tan the n minus 2 of x dx. Now the only bit of this we need to worry about is this, because this thing here is just the integral of tan the n minus 2. That is in minus 2, so it's sort of already done with the reduction formula bit. So we need to just sort out this thing, the left-hand part of it. But we know if you differentiate tan of x with respect to x, what you get is sec squared of x. So if you raise a power of this thing by 1, just sort of doing this by inspection, we're going to differentiate and see what you get. If you differentiate, what would that be by 1? N minus 1 if you raise it by 1. So tan the n minus 1. What you're going to get is n minus 1 times tan, so the n minus 2 of x times sec squared of x. Therefore, if you just integrate it, tan the n minus 2 of sec squared of x with respect to x, what you get is 1 over n minus 1 times tan to the n minus 1 of x. All right, so if you look back to this line here, I'll do it in yellow to show you which one I'm talking about. We now know how to integrate that first bit of it, and we now know what the second bit is as well. So therefore, your integral in is equal to, that's just going to be equal to, square bracket, that first bit is 1 over n minus 1 times tan to minus, it's times tan to the n minus 1 of x, and that's between the limits are 0 and pi over 4. And then the second bit, so this bit over here, is just in minus 2. Okay, fire in your values here of your limits. And we've got to want to tidy this up and do this again. You've seen this already a couple of times. This tidies up nicely. Tan of pi over 4 is just 1. So when you put in pi over 4, and then you've got 1, and then 1 to the power of n minus 1 to anything is just 1. So that just becomes 1 over n minus 1, and times 1, and then minus, and it's 1 over n minus 1, and tan of 0 is just 0. So that's just going to be 0, and minus in minus 2. So what you really have is in is equal to, that's just 1 over n minus 1 minus in minus 2. And again, that works for n is greater than or equal to 2, because you don't want to have that. That can't be any less than 0. So that's a reduction formula we have got. Okay, we're going to use that formula plus then our original integral as well. I'll write it down. What was it for the next bit? It was that in is equal to the integral from 0 to pi over 4 of tan to the power of n of x dx. So we're going to be using this and this to do the next part of the question. Okay, so I5 then is equal to, it's equal to a quarter minus I3, and then your I3 is equal to a half minus I1. And then what can we do then? Well, we have to just work out our I1. We can't go any lower than I1 with our reduction formula, so unfortunately we've just got to work out I1. So I1 is going to be equal to, and we're putting it into this formula on the left here. So I1 is going to be equal to the integral from 0 to pi over 4 of just tan of x dx. And that is one that's given in your formula booklet, thankfully. So we can put that into our formula booklet. Now look at our formula booklet, I should say, and you'll get ln of sec of x, and that's between pi over 4 and 0. And then sec we can't really do, but we can say that sec is the same as 1 over cos of x, and that's between pi over 4 and 0. So we'll just go up here to finish this off. So this is our I1 still we're on. So that's going to be ln of, and cos of pi over 4 gives you 1 over root 2. So reciprocal that, then you're going to get ln of just root 2. And cos of 0 is 1. So that's just going to be ln of root 2 minus ln of 1. And ln of 1, if you do that, if you've forgotten, ln of 1 in your calculator, it will just give you 0. So it actually just becomes ln of root 2, which is the same as a half of ln 2. Okay, I'm going to build up. I know I did it the other way last time, but I think these ones are a wee bit tricky to do. I'm going to build up to my ln 3. Ln 3 then is going to be a half minus a half ln of 2. And then ln 5 is going to be a quarter minus, and then that, whatever that was, my ln 3, which was a half minus a half ln 2. And then if you do that out, your I5 is going to be 1/4 minus a half is just a minus a quarter, and then minus a half ln 2 is a half ln 2, and then it's going to be minus 1/4, and that's it. Okay, last thing for this this one, I got through that a lot quicker than I thought I would. We have to find I6. So let me just write down my reduction formula again, that we have it above here. So my reduction formula we found was In was equal to 1 over n minus 1 minus I n minus 2. And also the original thing was In, and we might need this, is equal to from 0 to pi over 4. And it was tan to the power of n of x dx. So I6 then would be equal to 1 over 5 minus I4. We can then work out I4 is going to be 1 over 3 minus I2. I2 then would be equal to, where am I here, sorry. I2 would be 1 over 1 minus I0. And then I0 we can work out using this formula here on the right hand side. So I0 is going to be equal to the integral from 0 to pi over 4 of anything power 0 is just 1. So that's what we have. So let's just use a square bracket for that. That's going to be x between pi over 0 and pi over 4, and that's just going to be pi over 4. Then we'll piece that together again. We'll say then that means our I2 is equal to 1 minus pi over 4. Your I4 is a third minus 1 minus pi over 4. And we'll just work that out. And I got some mistake I made in the last one. It made it a wee bit awkward. That's going to be minus 2/3, then plus pi over 4. And then our last thing, just to keep that on the screen that we can see it then, do it here. I6 then is equal to 1 over 5 minus 2/3 and plus pi over 4. So if you do that, you've got 1/5. Just write it down, 1/5 plus 2/3 and then minus pi over 4. And if you do that out, you will get 13, is that right? Yep, 13 over 15 minus pi over 4. And that's it done. And that's the end of our reduction formula video.